Okay, so we're going to start making our review here for chapter 4. Okay, so I'm starting with the proofs, and I'm actually starting with proof 16. We're not going to do number 15. Number 14 we're actually going to come back to because you don't really have a question like number 14 on your test. So one of the things that you want to be able to get or understand or recognize is that when you're doing these proofs and you're told that you're proving that two triangles are congruent, you're using ultimately one of the triangle congruence proof, postulates or theorems. So you're either going to ultimately be using side, 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 or angle, side, angle, or side, angle, side, or angle, angle, side, or hypotenuse, leg. So as we go through these, we'll talk about how once you get to the end of the proof, you figure out which of these you're dealing with. But for example, hypotenuse, leg is only used when it's a right triangle. So if we have a right triangle, you're going to be like, oh, maybe it's hypotenuse, leg. But if we're not dealing with a right triangle, you know it's not hypotenuse, leg. So the very first thing we can write here for our statement is this whole given that's up here we can write down here. So we would actually put triangle ABC is an equilateral triangle and D is the midpoint of AC. So I'm not going to rewrite that all because mine will look really messy on here, but I can write given. Now in the next step they say side AB is congruent to side CB. How do we know that? Because it's an equilateral triangle. Actually, AB is congruent to CB. It's also congruent to CA. So my reason is actually definition of equilateral triangle. Now I told you guys, and I had you write down that if you're told that something is a midpoint, like you're told in the given, the next thing you're probably going to prove is what?
Definition of midpoint?
No, if you're told that something's a midpoint, then the next thing you're probably going to do is what's congruent? Two segments are congruent. So if D is the midpoint of this line AC, that means it's going to break it into two congruent parts. So it means AD is going to be congruent to CD. So I'm going to write AD congruent to CD. Now, when I do these, I'm exacting, and I say I want you to put AD congruent to CD because A is corresponding with C, and D is corresponding with D. The EOC is not going to be as exacting. And reality is I'm probably not going to take off full points if you don't put it in the correct order. But it's good to practice this. So AD is congruent to CD. That's definition of midpoint. So I now have two sets of congruent sides between these two triangles. The next thing they tell me is that BD is congruent to BD, which makes sense. These two triangles, ABD and CBD, share a side. So that side is congruent. BD congruent to BD is what property?
Reflexive.
Okay, it's reflexive, but you need to write the whole thing. You can abbreviate, but it's reflexive property of congruence. You want to make sure you put congruence. You can put the congruence symbol. You can write out congruence. You can write RPOC, even though some people get upset with me when I allow that. Okay? So we've now proved that we have three sets of congruent sides, correct? Have we proved any congruent angles? No. So the way we are proving that these triangles are congruent is by side, side, side. We have three sets of congruent sides. Okay?
Is that a theorem or postulate?
I think it's a postulate, but I'm not making you write whether it's a theorem or a postulate. Yes.
So side is when all three of the angles are congruent to the other.
Three sides, you said angles, when the three sides are congruent to the three other sides.
Okay.
Yes. Okay? So that was number 16. Now we're going to move on to number 17. And I have suggested to you guys repeatedly that when you are proving something involving overlapping triangles, this is CED and AB and DBC, and they overlap, I've said draw the triangles out separately. It'll be easier to see what's going on. So this is D, this is E, this is C. This is C, this is B, this is D. The first thing I'm told is that ED is perpendicular to EC. When two lines are perpendicular and they intersect and they're perpendicular, what happens? They create what?
Right angle.
They create right angles. So that means that when they form, they create CED, which is a right angle. The answer should be definition of perpendicular. Some of you are putting definition of right angle, and I'm going to accept that. But to be exacting, it's definition of perpendicular because the word here said perpendicular. I'm going to accept either. Okay? BD is perpendicular to BC, so I create another right angle. That's definition of perpendicular, but if you put definition of right angle, I'm going to accept it. Now, they tell me that ED is congruent to BC. And that's a given. I now mark that on my drawing. Okay? Now, I need one more step. And they tell me that it's actually DC is congruent to CD. If I look at those drawings, they share that side, correct? So what property is this?
Symmetric property.
It's perfect. It's symmetric property of congruence. And I know it's symmetric because DC is in a different order than CD. They're the same letters, just flipped. So CED is congruent, triangle CED is congruent to triangle DBC. By what? Well, let's look. They're right triangles, right? So when we have a right triangle, it's probably hypotenuse leg. But let's look. Did we prove that the hypotenuses of these two triangles are congruent? And did we prove that one set of legs of these two triangles was congruent? Then it is hypotenuse leg. Yes.
What's the leg in hypotenuse leg?
What's the leg? Just one of the sides. Whatever is not the hypotenuse, there's actually two sets of legs. Now, I want to point out here, technically, if I was grading this as a proof, I would prefer that you had for step 6, CD congruent to DC, because that's the order that they are when we're proving the triangles. But I'm not going to take off. That's an extra level of pickiness that I do because I think it helps you keep things straight. You following that? Okay, so that's number 17. Does that help you now start to see you pick which congruence theorem or postulate you're using based upon what you have? Number 18 on your test, you will have a drawing like this, and it will be a 2-column skeleton proof. In this one, though, I just ask you to kind of look at it and determine which theorem or postulate you're probably going to use. Are these two right triangles? So ideally, I'd like to use hypotenuse leg. Do they have one set of congruent legs? Is BD the shared side on both of them? And BD is the hypotenuse for both of those, right? So that's congruent. So therefore, I am going to use hypotenuse leg. Okay? Want to get some water, since throat's getting tired. And we're going to go on to 19 and 20. Now for 19 and 20, one of them is actually going to be proven angle, angle, side. And one of them is going to be angle, side, angle. And then we'll talk a little bit about how you know when it's angle, angle, side versus how you know when it's angle, side, angle. So number 19 is actually the same drawing, the same art is what we call it, as we're going to have in number 14 that we're going to come back to. So they're telling you that BAC is congruent to DAC. And angle B is congruent to angle D. So they've given me two angles, correct? Now, I want to find a side because is there an angle, angle, angle theorem or postulate? No. So even though I could prove these angles are congruent by third angles theorem, it doesn't help me. So I need to find a congruent side. Once again, I see they're triangles that touch, so they share a side. Now, some kids will say, well, Mrs. Falk, is it AC congruent to AC? Or is it CA congruent to CA? Or is it AC congruent to CA? So what I say is, look at what you're ultimately trying to prove. The final step has A before C on the part of the equation to the left, and AC on the part of the equation to the right. So AC congruent to AC is what?
Reflexive property of congruence.
So, look what happens when you actually take that leap of faith and say, I'm going to figure out how to do this. You get there, right? Okay. Now, so that means that's congruent. I have two congruent angles and I have a congruent side, correct? So this is where sometimes kids get confused. They say, well, Mrs. Falk, is it angle, angle, side, or is it angle, side, angle? It is angle, what? What do you think it is? It's not. It's angle, angle, side. Let me explain why. This was where it gets confusing. This is the side, correct? One of the endpoints of this side is also the vertex of these congruent angles, correct? But the other endpoint is not the vertex of the other congruent angles, is it? So angle, angle, side means the side comes in contact with the vertex of one of the angles, but not the other. That's why it's angle, angle, side. I have a drawing here. These are basically the same kind of art we just saw, right? This is what we just had. Angle, angle, side. Let's say we had the same drawing, but we ended up proving that these angles were congruent and these angles were congruent. Now, does this side come in contact with both vertices of both angles? So it touches both of them. So the side is in between the two angles. That's why this one is angle, side, angle. If now, just different problem, if I took the same art and said, well, the reason these angles are congruent is because they're both 90 degrees. Okay? This is not angle, side, side, is it? Because we don't have angle, side, side. Because let's say it on video, we can't have ass. Ass is not a thing, right? But it's this special case where we can make it PC, we can make it appropriate for middle schoolers, and we can call it hypotenuse leg. So this one is the same arc, but since that's a 90-degree triangle, 90-degree triangles, it's hypotenuse leg.
That's so much easier to remember.
What? Ass is so much easier to remember. Ass doesn't work. Doing things like an ass will get you nowhere. So that's angle, angle, side. Now we're going to do this one. And I'm going to tell you right now it becomes angle, side, angle. So let's look at this. AE is perpendicular to DC. And AB is congruent to DB. Okay? That's all given. Now, whenever you hear if two lines are parallel, then alternate interior angles are congruent. Then alternate exterior angles are congruent. Then corresponding angles are congruent. And then consecutive or same side interior angles are supplementary, correct? So you should, when you see this, be thinking you're going to use one of those theorems or postulates from chapter 3. They now do that. They talk about angle A and angle D being congruent. Yes. They're not corresponding. Here, let me make this, actually usually use some straight lines here to make it a little bit easier to see. That's a parallel line. That's a parallel line, right? That's the transversal. They are actually alternate interior angles. Now, ABE and DBC are what kind of angles? What? Vertical. And vertical angles are congruent by the vertical angles congruence theorem. That's one of the theorems you need to know for your quiz, right? Yes. If two angles are vertical, then they're congruent. Vertical angles congruence theorem.
No, I mean like how, like.
Okay? So in this case, it's kind of hard to see because the drawing is small. I have two angles that are congruent, right? And the side is in between them. The endpoints of that side are the vertices of that triangle. So the reason is angle, side, angle. Okay, does that help a little bit now? Little? Okay. So the last one we're going to do, okay, notice, are we proving that triangles are congruent? No. So, but if you look here in the proof, we prove triangles are congruent, and then we have one more step. We should start seeing a pattern. That last step is going to be corresponding parts of congruent triangles are congruent. When, yes?
I still don't understand.
Okay, let's wait till we get to the whole thing and then you'll, okay. Right now, can you memorize it if there's one step after triangles are congruent, it's CPCTC?
Yeah.
You can memorize that. We're going to get it so the end you understand that, okay? So, we're told PR and QS bisect each other. So they bisect each other at point T, correct? So T is actually the midpoint. We can actually fill in statement 3 before we can even fill in statement 2. T is a midpoint of what?
ER and QS.
Now, because they're bisecting, PT is congruent to RT. And ST is congruent to QT. Really, once you do that, you don't even actually have to have this thing about T as a midpoint. I just put it in there for extra practice. but it's extraneous. I'm not going to give you extraneous stuff on your test. Yes?
So no, is PT congruent to RT and then ST is congruent to QT because they share a midpoint?
No, because they're bisected.
Oh, okay.
They're not necessarily congruent to each other.
Okay.
Like, PT is not congruent to ST. Now, because I ultimately want to prove this is congruent to this, the vertical angles that I'm talking about are that angle and that angle. Technically, the red angles and the angles I'm going to draw right here with a black arc, the black arced angles are vertical also, correct? But they're not the ones that help me. Do you understand why they don't help me? Because I'm ultimately going to prove this triangle and this triangle are congruent. Okay? So, my vertical angles are PTS, I need an angle symbol there, is congruent QTR. I'm not that worried about which order you put them in, just as long as you get that they're the correct vertical angles. Now I've proved this side is congruent to this side, right? I've proved this side is congruent to this side. And I've proved this angle is congruent to this angle. Is the angle in between the two sides? That's why it's side angle side. Is the congruent angle in between the two sets of congruent sides? So I don't really care how you write these, but they do need to correspond. PTS is congruent to RTQ. And there should be a triangle symbol there. Okay? Now, do you remember when we had our quiz? And I told you triangle ABC is congruent to triangle DEF. And I had you write congruent statements. Do you remember this? Looking specifically at you, do you remember this? No?
No.
The quiz that we had. Okay? So you could write here, angle P is congruent to angle R.
Yeah,
And you could write T is congruent to T. Could you write PS is congruent to, it should be what? It should actually be PS is congruent to RQ, right? Now, could I then do a bunch of steps that say that RQ is congruent to QR by the symmetric property? Okay? So when I do all of this, I'm saying when I do those 6 statements, what I was doing was writing 6 congruent statements. The 6 congruent statements are all saying that corresponding parts of congruent triangles are congruent. That's what it stands for. You could write, since these 2 triangles are congruent, their corresponding segments are congruent. CPCTC is just a shorter way to write that. Now do you understand that? Yay. Okay? So, on your test, I'm telling you, you're going to have a few that deal with triangle congruence. You have one that does not. I'm telling you it's CPCTC. Now I'm going to go back on the review to number 14. And you will recognize the art, okay, from one of the ones we just did. BAC is congruent to DAC. And BD, B is congruent to D. Now, we just did one like this. We then proved that this side was congruent, correct? And we could then proved it by angle, side. If we did that, we could have done one more step and proved that these last two angles were congruent by corresponding parts of congruent triangles are congruent. This proof does not do that. Okay? This proof, the way it's written, does not deal with any triangles, does it? There's no triangle symbols there. So this proof is just there right now to help us have some extra practice.
Wait, you said it wasn't going to be like this on the test?
It's not like this on the test, but we're just doing some extra proof practice now. Because you guys always say to me, Mrs. Falk, I need more practice with proofs. So, angle BAC, which is this angle here, plus the measure of angle B, plus the measure of angle BCA equals 180 degrees. What theorem or postulate is that? No. It's triangle sum theorem. Angle addition postulate says two smaller angles add up to make the same larger angle. That's not what's happening here. We have three angles in a triangle. They add up to be 180 degrees. The next part of the proof takes the two things that were both equal to 180 degrees and sets them equal to each other. That is transitive property of equality. If this is equal to 180 and this is equal to 180, since they're both equal to 180, they're both equal to each other. Okay? Now, to get from step 4 to step 5, we're taking out the measure of angle BAC and we're putting in its place the measure of DAC. We're taking out the measure of B and we're putting in the measure of D. But we're not changing measure of BCA and BCA. So that's substitution. Okay? For number 6, we're taking DAC, measure of DAC and the measure of D, and we're taking them away, right? We're only left with the measure of BCA on the left-hand side. And on the right-hand side, we're taking out the measure of DAC and the measure of D. We're taking out the same thing on both sides. That's subtraction property of equality. And the last step is definition of congruence. Awesome. Okay? So that's what you have for proofs. Okay, so we're recording. I know it's noisy next door. They're watching a video or something.
Hello.
Well, it is Ms. Novak's birthday, so having a birthday party, I guess. So for number 1, they asked you to name a right triangle. So hopefully you got 35 plus 55 is 90. So A, B, C. Sorry, they wanted a right triangle. So ABC is your right triangle because ABC is your right angle. Okay, so number 1 was D. Okay. Number 2, they're actually doing the exterior angles theorem. The measure of this angle plus this angle is going to equal the exterior angle. So the red dot and 88 are a what? Linear pair. So that means this interior angle is how many degrees?
112?
No, this one.
102.
92.
92, yeah.
And this one and 127 are a linear pair. So it's 53. So 92 plus 53 will equal X, and the answer is D, 145.
They're called, it begins with an R. I don't I looked it up and it said the two angles.
Well, it's exterior angles theorem. The 92 and 53
92 and 53
are remote.
remote angles.
Okay, we don't use the term remote, but that's what it is. The non-adjacent interior angles are the remote angles, yes. Ooh, so I can't say his name because we're recording and there's like all kinds of like HIPAA violations. But that's great. He went ahead and he looked it up, or he was having troubles with it, looked it up, and saw that those are called remote angles. Yes.
Can you just say that 127 and the angle where it's 53, that those two are linear pairs, so you know that is 53, and then it's corresponding to x, so you know that x equals 127?
It's not corresponding though, and x is not 127. X is 145.
Oh.
There's no corresponding would mean you'd have parallel lines. You don't have any parallel lines there. It's exterior angles theorem. So for number 3, I hate this problem, but you add it all up and you solve for x, and what did you end up getting as your answer? D. I don't think you guys need me to actually go through that math. I think you can do 3x plus 2 plus 4x plus 2 plus x minus 1 equals 180, solve for x, and then plug it into each of those. Correct? Oh, good. So for number 4, basically this whole piece here is going to be a straight angle. It's going to be 180 degrees. So you need to find this angle and this angle to find x. So what I started doing was 130 and this angle are a linear pair, so this angle is 50 degrees, correct? If this is 50 and this is 90, this would have to be 40. And then the same thing here. If this is a right angle, this is also 90. We're actually using the corollary of the triangle sum to say that 51 plus this has to be 90. So that's what? 39. So 40 plus 39 is 79. 79 plus x equals 180. So x equals, okay, a lot of D's going on here. Number 5, okay? So number 5, I have two triangles, A, B, C, and D, E, F, but they're congruent. So I'm just going to make a little model here to help me. I'm going to say A, B, C. A to B is how many feet? 10. The measure of angle B is? Now, they tell me the measure of F. They don't tell me C and they don't tell me A. But if these are congruent, then C is congruent to F, correct? So C would be 14. So I can then use triangle sum, and I'll find the measure of A. So 180 minus 27 minus 14 is 139. Okay? They want which one is false. Is AC, whatever AC is it going to be equal to DF? Yeah, because they're congruent. Is C congruent to F? Now they say E is 139. E is congruent to B, but B was how much?
27.
So E is not 139. C is false, and they wanted which one is false. Do you get that one? Okay, number 6. And this is one of the things that kids ask questions on. They say, Mrs. Falk, how do I know when to use angle, angle, side, or hypotenuse, leg, or whatever the case may be? This is a right triangle. Okay? That means this is also a right triangle, correct? Now, normally, when I have a right triangle, it would be really great if I could use hypotenuse leg. But they don't tell me that any hypotenuses or any legs are congruent. They tell me that this angle is congruent to this angle. So technically right now, I have two congruent angles, right? Because if they're both 90 degrees, they're both congruent. They share a side. Okay? Now, that means it's either angle, angle, side, or angle, side, angle. It is actually angle, angle, side, but let me help you see why it's not angle, side, angle. If it were angle, side, angle, this side would be going through the vertice of both sets of congruent angles. It's going through B, which is the vertice of these two right angles, right? But it's going through D. Is D the vertice of angle A or angle C? No. So it's angle, angle, side. Yes?
So what is the vertice of the two angles?
Okay, this one of the vertices is B, and the other vertice is A and C. Okay? Now, a few of these we don't do. Number 7 and number 8, take them off. I'm not doing any translations on this test. We have a whole chapter on translations. I'll go over it later on. There actually are a few easy translation questions on your CFA, but we'll talk about that on Monday. You could, but we're not doing those. Okay? Number 9, the picture did not show up on your test. So the picture is that of a triangle with side lengths marked 2x minus 1 for AB. AC is 9, and this actually says x plus 4. So draw that triangle on your review, because you do have a question with a picture like this. So make sure you draw that. They're actually asking you if ABC is an equilateral triangle. They tell you that AB is equal to BC. Okay? So I've done this a few different ways in a few different classes, but let's say 2x minus 1 equals x plus 4. So we're going to solve for x. If I subtract x on both sides, and I add 1 on both sides, I get x is equal to 5. Is 5, so plugging this in, 5 plus 4 is 2 times 5 is, minus 1 is this equilateral? There you go. Now for number 10, the one I give you on the test, I change this, I'm not having you write converses, just tell me if it's true or false. So even if you don't have a clue, you got a 50-50 chance, right? Now, if you have a triangle and two angles each measure 60 degrees, well, all three of them have to measure 180, right? So if 2 equals 60, 60 plus 60 is 120, the last one is also 60, correct? So if all of these are 60 degrees, this triangle is equilateral, is equiangular, correct? But we learned a theorem that said if a triangle is equiangular, it is equilateral. So this is true. Okay? Yes?
So you only need to have two angles to know if it's...
No, you only have to have this because think about it. They all have to add up to 180, right?
Oh,
60 plus 60 is 120. 180 minus 120 is 60. Okay? Now, for number 11, you're told about a perpendicular bisector, but we have not learned about perpendicular bisectors. So on your test, it says, find the measure of M if, and I put a point P there, and I write if NP is congruent to MP. So if these sides are congruent, the base angles are congruent, right? By the base angles theorem that we learned yesterday. So I can set these equal to each other. 8x minus 12 equals 5x plus 18. Do you understand how I set those equal to each other? Do you understand that? So I'm going to subtract 5x from both sides. I get 3x. I add 12 to both sides. I get 30. If 3x is equal to 30, x is equal to, and then I'm going to plug this in for m. 5 times 10 is 50, plus 18 is 68. Okay? And for number 12, I'm going to draw a triangle here. It's always best to draw a picture. I'm going to call A, B, C. I'm told that AC is 3 times the length of AB. So if I call AB X, AC is 3 times X, correct? Okay, and I'm told that AC is equal to BC. So if AC is 3X, BC is 3X. 3X plus 3X is, plus one more X is, if 7X equals 35, X equals, they wanted to find the length of each side. So AB is 5, BC is 15, and AC is also 15. Okay? You do not need to do problem 13. That's actually all you need to do for on the test. Now, hold on. I'm going to pause this. I'm going to stop this.